Let's start playing around with the set S and look at some numbers that are in it and see if maybe we can see a pattern. We know that S contains the number 2, and if it contains the number n, it also contains the numbers 3n and n plus 5. So 3n in this case would be 6, and if we took 2 plus 5, that would give us 7. So we've got 2, 6, and 7. But because 6 is there, we could let 6 be n. We know that 3 times 6 is in it. That means that 18 is also in it. But also 6 plus 5 is also going to be in it, and 6 plus 5 is 11. So we've also got 11. And we can do the same with 7. 3 times 7 is 21, so that means 21 is going to be in this set. And then 7 plus 5 is going to be 12, so 12 is going to be in the set. And we can keep doing this as much as we want with all these numbers. We can look at 18 and take 18 times 3. We end up getting 54. Or 18 plus 5, we get 23. So those numbers are also in the set. Or we could take 11. 11 times 3 is 33. And 11 plus 5 is 16. So these numbers are also in the set. And we could keep going and going and going and listing more and more numbers. But there's one thing that we notice. So far, none of the numbers are a multiple of 5. But we have to make sure that we won't eventually get a multiple of 5. And I'm going to claim that that's not going to happen. Remember that when we start off with a number, the way to get new numbers in the set is to multiply by 3 or add 5. If we don't start off with any multiples of 5, when we're multiplying these numbers by 3, that's not going to create a new multiple of 5, because if we didn't start off with a factor of 5, multiplying by 3 isn't going to add 1 in. Also, if we start with numbers that aren't divisible by 5, and we add 5 more, the resulting numbers aren't going to be divisible by 5. So none of these methods are going to result in a multiple of 5, which means there are not going to be any multiples of 5, which means that the number 2000 can't be in the set, and that means our answer is answer choice A.